We said that the key words here are isolate and separate. So I need to isolate this absolute value. It is not isolated right now. I need to solve for P. What would you do first in this problem?
Subtract.
What would you subtract? Yes. This 9 is over by itself. It is not connected. So I'm going to subtract 9. Whatever you do on one side, you must do on the other. The 9's cancel out. -3 times P plus 6 in absolute value equals, what is -3 minus 9? Yes, -12. And this is where I said some of you might get in some trouble with the positive negatives. Rashawn, what would you do next in this problem? Or what did you do next? You added -12 to -3? Is that what you said?
No. What I did, I don't know how to explain it correctly, but what I did was I added 12, -12, and canceled that. Then I added 12 to -3.
Added -12 to -3. Yeah. Now we're trying.
Same thing you did with the 9. I just added 12.
You added 9?
No, what I'm saying is, same
sorry.
thing you did with the -9.
Yeah.
There, I just did the same thing, but with -12, I just added the opposite.
So you put a plus 12 here?
Yeah, and I'll put it on the other side.
Okay. Now, you need to keep in mind our end goal, because we're trying to isolate this absolute value of P plus 6, right? So I'm trying to get that isolated. So I don't think we want to add 12 there. What I want to do is undo this -3. Yeah, right now it's being multiplied. Okay, and we don't distribute when you have absolute values. We don't distribute. So we divide by divide by -3, divide by -3. The -3's cancel out. And I have the absolute value of P plus 6 is equal to -12 divided by -3 is +4. Is that isolated on one side of the equation by itself? Yes. So what do I do now?
Subtract.
Separate, right? Isolate and separate. Isolate and separate. So this becomes P plus 6 is equal to the +4. And on the other side, P plus 6 is equal to what? -4. All right, so we subtract 6, subtract 6. 6's cancel out. P is equal to -2. Subtract 6, subtract 6. And P is equal to -10. Gentlemen, I am sure you are, but it wasn't that funny.
We switched packets. We didn't mean to.
Okay, that is kind of silly. All right, I'm going to show how to do the check, because we really kind of should check and make sure these answers are somewhat correct. So here's for the first one where I substituted in -2. -2 plus 6 is 4. Absolute value of 4 is 4. 4 times -3 is -12. -12 plus 9 is -3. So -3 equals -3. That one works out. And let's do the check with P being equal to -10. I'm going to do that up here. -3 times absolute value -10 plus 6 plus 9, is that equal to -3? -10 plus 6 is -4. Absolute value of negative 4 is positive 4. Negative 3 times positive 4 is negative 12. Negative 12 plus 9 is negative 3. Negative 3 equals negative 3. Brian, come on. Head up. You all right? Yeah? Get it, your card. You have a card? Fill it out and I'll sign it. Any questions about this absolute value? Does that make sense a little bit now? Okay. All right. So the second one we've dealt a little bit more with. First of all, I'm going to ask for answers. What did we get for an answer for A? Ty, did you get that problem? The second one? No? How about Alexandra? Did you get to that one? You guys, come on. Osmond, what'd you get? What'd you get for A in the second problem? Did you get that? What'd you get? I'm just checking. A is 17? 17 halves?
Or 8.5.
Okay. Angel, what'd you get? Did you get to that one? 8.5, which is the same. Okay, thank you. All right, well, let's take a look. 7a plus 5 equals 9a minus 12. Do I need to combine like terms on the same side? No, I can't combine like terms. So I need to get my a's on one side and numbers on the other. I'm going to subtract 7a from both sides. 7's cancel. I get 5 equals 2a minus 12. Get my numbers to the left by adding 12. And I get 17 is equal to 2 times a, divide by 2. And you can leave it as a equals 17 halves, or you can take that to be a is equal to 8.5, or you can say a is equal to 8.5. All of those are correct. Brian, you got it? Come on. Any questions on that? All right, let's go into our notes. We are on the last day of absolute values. I believe it's on page 17. It's on the back. Okay. So page 17. And I am recording this. You will be able to see it later. I also have scanned things. I don't have them all uploaded yet, but you should be able to check some of those things. Okay, let's see here. negative 9, and I know when I see that negative with an inequality, I need to switch the sign. So it is now less than. I am solving for x. So I'm going to add 7, add 7. 7's cancel out. 4x is greater than 16. Divide by 4, divide by 4. X is greater than 4. Now, I didn't write down the divide by 4. As you guys, I think I said this the other day. Maybe I didn't. As you get up in your math, you don't always have to show every exact step because people usually can see, oh yeah, we divided by 4 on both sides. Okay? Over on the other side, add 7, add 7. 4x is less than negative 2. Divide by 4, divide by 4. There I'm showing it. X is less than negative. And if I divide by 2 over 2, I get 1/2. Okay? These are both open circles because I don't have the equal sign. So x is greater than 4. Does that include 4? And x is less than negative 1/2. So negative 1/2 is between 0 and 1. And it's less than that. So this is what we call an or statement because it looks like the boat oars. You put in like a canoe or a fishing boat. And so I would say, doing this value that's on the left, x is less than negative 1/2, or x is going to be greater than 4. That is your or statement. Yes? Right now? Did she ask you a question or something? It just came to you that you should email her? I guess.
I'm trying to see if I can get a study hall.
Okay. Yes.
Do we only flip the sign when like both numbers are negative?
Say that again. Do we?
Do we flip the sign when both numbers are negative?
When both numbers are negative. We flip the sign. Are you talking about up here at the top?
Like at the bottom here.
At the bottom. Okay, we flip the sign when you are dividing by a negative or you are multiplying by a negative. So here, once I flipped it up at the top, and you were not here yesterday, right? So when you set it equal to the second case, which is a negative value, we definitely flip it up there. And when we get to the bottom, if we have multiplied or divided by a negative, that's when we flip it. Oh, I see what you're saying. Why did I put the x is less than negative 1/2 on the left? Is that what you're saying? I did not flip it. Just because it's negative, you have to divide by a negative. And here I was dividing by this positive 4. So I did not flip the sign. Does that make sense? Does that answer your question? Maybe I'll come to you in a minute. Because I don't think, obviously, I am not getting your question. Okay. All right, let's go to C. C, I do not have my absolute value isolated. So let's isolate it. Am I going to undo the 4? Or am I going to undo this negative 3? The 4. The 4 is by itself. The negative 3 is close to what I want to isolate. So get rid of the 4 first. And that is a positive 4, so I will need to subtract it. Yep. So minus 4, 4's cancel out. Negative 3 times the absolute value, 2x plus 6, absolute value is greater than negative 30. Negative 3 is being multiplied by this. So I want to divide by negative 3, divide by negative 3. So the absolute value of 2x plus 6, we just divided by negative 3, so that's the wee-oo, wee-oo. And negative 30 divided by negative 3 is positive 10.
Yeah.
Now I've isolated my absolute value, separate it into your two cases. So I have 2x plus 6 is less than 10. And 2x plus 6, I'm comparing it to a negative 10, which means I had to divide by a negative again, and I flip it again. So 2x plus 6 is greater than negative 10. Put the phone up on your desk. Put it on your desk, face down. And just keep it there. Nope, up, high. Yep, right there. Does everybody see how I had to flip it again? Nobody's answering. Okay, so let's solve for x. Let's subtract 6, subtract 6. 2x is less than 4. Divide by 2, divide by 2. X is less than 2. And on the other side, subtract 6, subtract 6. 2x is greater than negative 16. Divide by 2, divide by 2. I didn't divide by a negative, so I'm not going to flip. So the sign stays the same. X is greater than negative 8. Did I keep the right sign? Yes. So I still have open circles at 2 and at negative 8. X is less than 2. X is greater than negative 8. So it's going in between. Is that an and compound inequality or an or? That's an and. So, and they're on different wrong sides though. The negative value, this one over here, is more on the left, so I will write that one first. X is greater than negative 8, and x is less than 2. Questions on that? Let me take a look at these. Let's see if we can do D and then maybe one more. Okay, so D, I have 5 times absolute value negative 5 plus 3x and absolute value minus 3 is greater than or equal to 22. The absolute value is not isolated. What would you do first?
Divide by +3.
Yes, I need to add 3. Here's that negative 3 all by itself. So add 3, add 3. 3's cancel out. 5 times absolute value negative 5 plus 3x is greater than or equal to 25. I'm trying to isolate that, so divide by 5. Divide by 5. And I get absolute value negative 5 plus 3x. And absolute value is greater than or equal to 5. Greater than or equal to. Now I can separate into my two cases. Negative 5 plus 3x is greater than or equal to 5. And negative 5 plus 3x, I need to compare that to negative 5, which means I had to divide, which means I need to flip the sign. So it's now less than or equal to. Solve for x. Add 5, add 5. 5's cancel out. 3x is greater than or equal to 10. Divide by 3, divide by 3. X is greater than or equal to 10/3 or 3.3 repeating or 3 1/3. That's one answer. On the other side, add 5, add 5. You okay? Cancel out. 3x is less than or equal to 0. Divide by 3, divide by 3. X is less than or equal to 0. Are these open circles or closed circles? Closed. Why is that? The equal sign. So those values are equal. I need to show that. So I need to put a closed circle on 0. And we are going less than 0. Less than 0. And x is greater than or equal to 3 1/3, which is going to be a little past 3. Closed circle. Going this way, it's greater than. So this is an OR statement, or compound inequality. And I'm running out of room. So I am going to say that x is less than or equal to 0, or x is greater than or equal to, I'm going to leave it as 10/3. But you can say 3.3 repeating or 3 1/3. Okay? All right. Let's see. I want you to try F on your own. Everybody try F on your own. If you want to do E, you can, but I really want to see F. Extra practice. All right, so everybody try F. Everybody try F. Let me know if you need help getting started. Need a hint, help, suggestion. Everybody try F on your own. This will be our last problem for notes today. It's taking you this long. Well, if you sent it, don't worry about it. For now, you need to focus on this, okay? You need this class, right? Okay. You have a question? How does this seem? A little overwhelming? Okay. Well, let's try to get started here. So, is this absolute value isolated? Is it by itself? No, we've got 4 times it, and then we got plus. Okay, this one was by itself. See how it's the only thing over there? That's what we mean when we say isolated. So, when we have 4 times something, and then plus or minus something else, we want to get rid of the number that is not close to your absolute value. So this is a positive 8, so you would, yes, both sides. And 8's cancel out. And 24 minus 8, good. It's going to give you positive 16. And then bring down this. 4 times absolute value. and we want to get the absolute value by itself. This is 4 times this, so you're going to divide. You always want to do the opposite. So divide by 4. On this side, divide by 4. 4 simplify out. So now bring down your absolute value on the left. And on the other side, what is this number? I can't tell. Upside down. 16 divided by 4 is 4. Now, we need to bring down that symbol so it's less than or equal to. Now it's isolated. So now I can take it into my 2 cases. So you're going to say 6 minus 2x. And whatever this symbol is, so is less than or equal to the positive, which is 4. And then your other case over here is 6 minus 2x. And you're comparing it to negative 4 because it was in this absolute value, right? Now, because we are comparing it to the negative, we flip the sign in between and put is greater than or equal to. There you go. Now we need to solve for x in both of them. So you want to get rid of the 6 by subtracting. Yeah. I don't really know the answer.
That's the right answer.
Then there you go. Can you graph it?
I did.
Oh, is it in between?
Yes.
I would show, yeah, right. There you go. All right, so here's what I think it should look like. I'm going to go through this quickly because most of you have already started ahead. Okay. Here in letter F, it is not isolated. So I am going to subtract 8. 8's cancel out. 4 times 6 minus 2x, absolute value, is less than or equal to 16. Divide by 4. 4 simplify out. The absolute value, 6 minus 2x, is less than or equal to 4. Now it's isolated. I can go into my 2 cases. So I say 6 minus 2x is less than or equal to 4. That's the positive. And 6 minus 2x, compare it to negative 4. I am switching and flipping the sign. So this is greater than or equal to. Then we subtract 6 from both sides. Negative 2x is less than or equal to negative 2. Divide by negative 2. Divide by negative 2. Holy smokes. I got to flip this one now. Wee-oo, wee-oo, because I divided by a negative. So it is now greater than or equal to 1. Over on the other side, subtract 6, subtract 6. Gentlemen, every time I think I'm going to have extra time, I don't. Divide by a negative 2. We're dividing by a negative, so you've got to flip it again. So x is less than or equal to 5. So I've got 1 as a closed circle and 5 as a closed circle. X is greater than 1 and x is less than or equal to 5. So that is an and statement. X is greater than or equal to 1 and x is less than or equal to 5. Does anybody have that?
Oh,
Yes.
yeah, I had that.
Good job. All right. So I will upload this video later. Your homework tonight is to complete
The backside of the homework.
the back side, or if you didn't start the front side, this is Module 9, Homework 2. It is due tomorrow, Wednesday. And if you're not watching the announcements, go ahead and start it. Get her done. Get her done. Okay? All right. Let's see what the announcements are about today. Announcements.